Today, we're going to do day 2 of our inverse trig functions, and the main theme here is it's going to be a composition of a regular trig function with an inverse trig function. And first thing we're going to do is take a look at this and make an observation. For this particular example sheet, numbers 1 through 9 all have the same orientation to them. The outer function is an inverse, and the inner function is a regular. And then what happens for the bottom part of today's examples is we switch the orientation. The inner function is an inverse, and the outer function is a regular. All right, as a quick review, yesterday we talked about the idea if you have this arc sine, arc cosine, arc tangent, or the traditional sine -1, cosine -1, tangent -1 notation that's already part of the problem, such as we have here, then we have to work under these intervals. Domain, -1 to +1 inclusive for arc sine. Important thing is, new to yesterday, is that when we answer something that has this notation, that y value we give back has to be from -π/2 to +π/2 inclusive. Okay, domain of arc cosine, -1 to +1, not really new to yesterday. The range is the new thing, that if we answer something that's already in arc cosine notation, the answer we give has to be in that interval. And then for arc tan, we have these intervals here. All right, we're not going to do all of these, and we're going to skip around a little bit just to give you an overall flavor of the different things that can occur. All right, starting off with number 1, we have the arc cosine of the sine of π/6. All right, the same as it's always been in your previous algebra classes. If you have a composition of functions, you start at the inside and work your way out. So the first thing we're going to do is evaluate sine of π/6. Okay, that's a number that we can get directly from the unit circle. Sine of π/6 is a half. Okay, after that first move, now we're back to last night's homework. What's the arc cosine of 1/2? Which means the cosine of what angle is a half, but the answer we give has to be between 0 and π. So cosine being a half, in general, prior to yesterday's lesson, we would be answering that as π/3 and as 5π/3. We only want the 0 to π interval, so the answer that we're giving is π/3. Okay, next one that we're going to skip down to is number 4. The arc cosine of the cosine of π/3. Okay, well, cosine of π/3, we can get that directly from the unit circle. Cosine of π/3 is a half. And then the arc cosine of 1/2, we're actually back to the last question we just did. We just answered that as π/3. So what's happening here is arc cosine and cosine, those are inverses of each other, so they're undoing each other, getting us back to π/3. Now that's going to be true as long as that π/3 fits that interval. Now in contrast, let's look at number 5 next. Arc cosine of the cosine of 7π/4. Okay, this has the potential to undo itself because arc cosine and cosine are inverses of each other, but 7π/4 is not in the 0 to π interval. We can't answer this question 7π/4. If it's an arc sine, it has to come from that interval. So here's what we need to do. Cosine of 7π/4. 7π/4 is down here. Cosine is √2/2. And then for the second step, the arc cosine of √2/2 is the cosine of what angle is √2/2, but coming from that interval. So if we limit ourselves to the 0 to π interval, the cosine of what angle is root 2 over 2? It's pi over 4. All right, we're going to do one more of those. I'm going to jump up to number 3. The arc sine of the sine of 9 pi over 2. These have the potential to just undo each other and leave a final answer of 9 pi over 2. If 9 pi over 2 fit in this interval here, we'd be done. That's the final answer. It's not, so we have to break this up into the 2 steps. So, inside part, sine of 9 pi over 2. Well, that's the same as the sine of 4.5 pi. So 2 pi, 4 pi, half pi puts us up there. The answer is 1. And then, for the outer part, the arc sine of 1 is the sine of what angle is 1, but the answer we give has to come from that interval, so that'll be pi over 2. All right, the next one we want to jump down to is number 7 here. The arc sine of the sine of pi over 5. These have the possibility of undoing each other. As long as this fits in that interval, we're good. Pi over 5 is in between negative pi over 2 and, oops, you almost can't see that, positive pi over 2. So the answer is just pi over 5. Now this one here, if we didn't recognize that as a shortcut, we'd have a difficult time evaluating this without a calculator. Because the sine of pi over 5, you can't get that answer from the unit circle. So without using technology, you're pretty much forced into knowing that that's a rule. Okay, level up in terms of one level of difficulty harder than this one. The arc cosine of the cosine of 8 pi over 5. Okay, if 8 pi over 5 fit in this interval, the answer would be 8 pi over 5 because these are inverses of each other. It's not, so that means we have to do this as a 2-step. But we're not going to be able to use the unit circle because 8 pi over 5 is not a value that's on the unit circle. So what we're going to do is locate, well, where is 8 pi over 5? Okay, 8 pi over 5 is 1 3/5 pi, which is a little bit more than 1.5 pi, which means it's down here. Okay, so that reference angle is 2 pi over 5. So that means we need to find an angle that's in the 0 to pi interval that has that same reference angle. Oops. I don't know why I went over there. I apologize. I'm going to start that over because now that is very difficult to read. So we've located 1 3/5 pi is roughly down here with reference angle of 2 pi over 5. Now what we have to do is pick an angle in the 0 to pi interval that has a reference angle of 2 pi over 5. We have 2 to choose from. We could pick the first quadrant option, or we could pick the second quadrant option. I made the mistake of picking the second quadrant option. The first quadrant option is the one we want because in the first and fourth quadrant, cosine is both positive. If we chose this one, cosine would be negative, and then that would make the answer incorrect. So when we have to go to a different quadrant, like in this particular problem, we have to make sure we go to the one where the SI, G, and S's agree. So the first quadrant angle that has a 2 pi over 5 reference angle is 2 pi over 5. Okay, the solutions to the rest of these guys are posted in Google Classroom. You can try the rest of those on your own and check those answers over. All right, what we're going to do now is we're going to reverse the order, which means now the regular trig function's on the outside, the inverse is on the inside. Similar to the problems above, Some of these we can get by working directly off the unit circle. Some of these we need to be a little bit more creative than just using the unit circle. All right, let's see if this is going to be up here. Let me get another page that we can use for referring to the inverses. I'm sorry, the intervals, not the inverses. All right, let's do this. So we don't have to keep sliding another page. Just take that right there so it stays nice and clean. Now we can refer to the intervals when we look up here. Okay, number 10. This is one we can get directly from the unit circle. The secant of the arc sine of 1/2. The arc sine of 1/2, we can evaluate that right from the unit circle. The sine of what angle is a half, making sure that we answer in this interval right here, pi over 6. Now for the second part, what's the secant of pi over 6? Secant is the reciprocal of cosine, so it'll be the reciprocal of the x-coordinate. And we're done. All right, the rest of the ones that we're going to be working on from this section, we're not going to have the ability to just extract numbers from the unit circle. So if we were to try to take that same strategy with number 11, the cosine of what angle is 2/3? 2/3 doesn't appear on the unit circle anywhere. So the unit circle is not an option in order to get this done. So here's how we're going to have to approach this. Paper here. All right, arc cosine of 2/3. That means the cosine of what angle is 2/3. In this notation, that means that we need to be working with an angle that's somewhere between 0 and pi. Which means we need to either be sketching a first or a second quadrant angle. Cosine is positive in the first quadrant, so that's where we're sketching it. So the cosine of one angle, that's my angle right there, is 2/3. 2/3. Pythagorean theorem, so that's 9 and 4, this is root 5. Now the second part is what's the tangent of that angle. So the tangent of that angle, opposite over adjacent, root 5 over 2. So contrasting it to number 10 again, we can evaluate the inside part by simply extracting a number from the unit circle. That's not always possible. When that's not possible, we sketch the angle that's being described by that inner statement and then use that sketch to answer the outer part. Okay, we're going to do number 3 next. I'm sorry, number 12 next. The cosine of the arc sine of -3/5. We can't evaluate arc sine of -3/5 in the unit circle. -3/5 does not appear in the unit circle. So we have to sketch an angle to represent it, or make a sketch rather, to represent that inside angle. So, if it's arc sine, that means we need to be dealing with -pi/2 to +pi/2 is where we're sketching it, which means we're either drawing a first or a fourth quadrant angle. Because sine is negative here, we have to draw it in the fourth quadrant. So sine, opposite over hypotenuse, that makes that side 4. So this sketch represents what's being described by the inside part. What's the cosine of that angle? 4/5. Doing number 13 next. The cotangent of the arc cosine of -5/13. We cannot evaluate the inside part by extracting a number from the unit circle. This means we have to make a sketch. Cosine being negative occurs in, well, actually back it up. If it's an arc cosine, it means we have to choose between the first and the second quadrant, because the interval is 0 to pi. Cosine being negative means we have to be sketching the second quadrant angle. So the cosine of that angle, negative 5/13. That makes the missing side 12. Okay, now that we have a picture or a sketch to represent the inner part of this expression, now we're going to take the cotangent of that angle. Tangent would be opposite over adjacent, cotangent adjacent over opposite, negative 5/12. All right, I'm going to skip to number 15. The sine of the arc sine of 3/7. These guys have the ability to cancel each other out because of the fact that they're inverses of each other. As long as we don't have any violation in terms of domain range stuff going on, the answer is just going to be 3/7. Well, arc sine of 3/7. Well, you can take the angle, the sine of an angle, and get 3/7. So we don't have any issues there. So that would be the only thing you really have to worry about. So the final answer is just 3/7. All right, next one we're going to is number 17. This one is in contrast to number 15. Sine, arc sine, sine, arc sine. So these guys have the ability to cancel each other out. The issue we have to look at here, 8/7. Can you take the sine of an angle and get 8/7? You can't. You can't take the sine of an angle and get something bigger than +1 or less than -1, which is why the domain of that is -1 to +1. So here, there is no solution. We are stopped right there. Arc sine of 8/7 is an undefined expression. Okay, last one, number 18. The tan of the arctan of 15/11. Okay, we have the ability to potentially have these guys cancel out and just leave us 15/11. Now the main thing we looked at with these two was the fact of, is that more or less than 1? The domain of arc sine is -1 to +1. The domain of arc cosine is -1 to +1. You can't take the inverse sine of something that's outside that interval. You can't take the inverse cosine of something that's outside that interval. The domain for arctan is all real numbers, so we don't have to worry about that. There's nothing going on that could happen as long as that's some real number. With tangent, arctan, they'll always cancel each other out. So that's just going to be 15/11. All right, for tonight's worksheet, the information is going to be presented slightly different than the example sheet that we just did. What we have here is the problems being presented in function notation. They're defining function f to be sine of x. They're defining function g to be cosine of x. Defining function h to be tangent of x. So for number 67 here, g of f inverse of 12/13. Translating that to make it look like the problems that we just did, the outer function is g, that's cosine. The inner function is inverse of f, which is inverse sine. And then 12/13, which is the same thing as cosine, arc sine of 12/13. These two mean the same thing in terms of what we're doing. So once you get from that notation to this, then it's going to marry up exactly with one of the examples that we just did. So, arc sine of 12/13. The sine of what angle is 12/13? That number cannot be extracted from the unit circle. So if it can't be extracted from the unit circle, we're going to sketch a picture. If this number is positive, regardless of the trig function, we're guaranteed to be first quadrant. So the sine of this angle is 12/13. That makes this 5. If that's negative, then you're going to be choosing between whether you draw it here or draw it here. If it's an arc tangent with a negative or an arc sine with a negative, that always puts you in the fourth quadrant. If it's an arc cosine with a negative, it always puts you in the second quadrant. And that follows those intervals that we've now been talking about for close to 2 days. Now, as far as wrapping up the rest of this problem, what's the cosine of that angle? 5/13. All right, so that is a wrap in terms of what we need to know for today. What's going to happen tomorrow is we are going to look at a composition of functions where this this innermost thing right here, which has been some number, is going to be an algebraic expression. And that'll be as far as we take this topic with that idea tomorrow.